Hey, welcome back to Geometry. This is Chapter 12, Section 5. We're looking at the volume of pyramids and cones. Okay, we talked about the volume of prisms previously, and we found that the area was the base times the height, and that was the area of the base. The volume, how much fits in there, is the area of the base times the height. Now we have pyramids. Now, this pyramid has the same base area. So, these have the same area of the base, same size base, just this is a pyramid. Okay, we want to figure out how does this volume compare to this one. Notice they also have the same height. Okay, so I can place this in here, and it fits in there perfectly. It has the same height, and it has the same base area. Okay, now to figure out the volume, I can fill this one up. And then I can dump that in here. And see how much of the volume is that. Now if you were to look at that, you can see, I don't know whether you can see that, okay, it's below the halfway mark. Okay, that's about a third. And actually it should be, if we've done it exactly, it should be exactly 1/3. So the volume of a pyramid is 1/3 that of the prism with the same base area and the same height. So we have a pyramid with a volume of 1/3 base times the height. The same goes for an oblique pyramid, where we have the same area and the same height. Those would have the same volume. Now what about a cylinder and a cone? Now again, we have a cylinder here and a cone that have the same base area and the same height. So I can fit that in there. Fits exactly inside there. Oh, there we go. Fits in there to the height. Has the same base area. Okay, so the cylinder relates to the cylinder relates to the cone, or the cone to the cylinder, in the same way that a pyramid relates to a prism. And we can have a look at that. Fill this up. Oh, we can get a little more in there. There we go. All right, that's pretty full. Okay, and again, here if we look at this, there, notice that's a little below halfway. That is also a third. So same relation here. The cone relates to the cylinder in the same way that a pyramid relates to a prism. It is 1/3 of the base times the height. And since the base is a circle, that's pi r squared times the height. And the same thing goes for an oblique cone. So here's an example. If they're going to be mean to you, and instead of giving you the radius or giving you the diameter, they put an angle in there. And then I'll walk you through what we're going to do to get around this. If I know this angle down here, and I know the height, and here's a right angle, then I can use Sohcahtoa. So now remember, the volume is 1/3 pi r squared times the height. Well, I don't know the radius, so I'm going to try to find that. So I can find that using the tangent, since I know opposite and adjacent. The opposite is the 11, the adjacent is the radius. So I'm going to do tangent 58, opposite, adjacent. Now I have to solve this for r. So I'm going to multiply by r, and then I'm going to divide by tangent 58. And now I can simplify that, type that into your calculator. That's approximately 6.9 for the radius. Now that I know the radius, I can plug it in for the radius in my formula, and the height is 11. And then work that out. We get approximately 548.4 inches cubed. And that's all the fun we're going to have today.